afternoon. My name is Peter Huck. I'm a founder and chairman of a Redstack company. And we're using a reverse electrodesalination process, I'll explain later, to generate large quantities of sustainable and full continuous power. We are a spin-off of the Redstack Research Institute. We have some patent portfolio of some 50 worldwide patents. 50 million has been invested so far in this technology. And we are operating worldwide the first pilot plant or real environment. The King of the Netherlands came to do the ribbon cutting ceremony at our pilot plant, and the Dutch Cabinet of Ministers has awarded us the title of Dutch National Icon, meaning that they are convinced that we are solving a societal problem in an ecological way and also good for economy. Let me explain where we are focusing in. In the energy transition, we are installing large quantities of wind and solar parks, but no sun, no wind, no power. Our technology will use the salt gradient, water, and make a full continuous power available, thus reducing the need for conversion and storage systems with their inefficiency and costs. How does it work? We use the difference in salinity between the freshwater, a river, and the sea, the salt water. We use two types of membranes. One membrane where the positive part of the salt, the sodium, can pass through. Another type of membrane where the negative part of the salt, the chloride, can pass through. And we stack them alternately. And then the water flows in parallel. The freshwater, saltwater flows in parallel. What happens then is that the salt starts to move from the saltwater flow, the seawater flow, into the freshwater flow, a natural process driven by natural laws, physical laws. Then all the positive parts from the sodium, from the seawater, pass to the left side from the salt to the fresh water. They cannot pass into the other direction because the membrane stops them. The negative parts move to the right because they can pass through that membrane. So all the pluses to the left, the negatives to the right. You have a plus and a minus, you have a DC source. Per membrane, you harvest about 50 millivolts. That's nothing. But when you have a pile of 1,000 membranes, you have 50 volt DC. 2,000 membranes is 100 volt DC. What is the potential? Looking at the world where the rivers flow into the sea, where it is a bit warm, where you have a gradient between fresh and salt, and a bit not taking all the water, the fish and ships also of course have to pass. The worldwide potential is 1 terawatt. There's a million megawatt. But we're starting small, to be honest. This is our pilot plant, the first plant out of the laboratory in the real man's world. The right-hand side, you see the freshwater, the lake from the River Rhine. The left-hand side, you see the North Sea, the Waddenzee water. And the blue building is our pilot plant. This is the left side top is the pre-filter to take all the algae. We do not want that in our facility. And the right and other pictures are where our test facility is the membrane stacks. We started with a small stack of a liter about, and now we have make the 2,000 times bigger with a nice capacity. Although from a size of a village, not yet. The blue ones left right top is the sequential, and the lower ones are how it is going to be. Multiple modules in a large arrays with big power plants. They will look like this. So what are we doing? We are developing the upscaling process. The next phase will be a 3 megawatt tier level 9 power plant. And later we go to the 100 and the 500 megawatt power plants. But it's a long way to go. The permitting, licensing procedures, it's not that fast. So in the meantime, we will use the same technology, the same hardware to solve other problems. We can use exactly the same hardware in desalinating brackish water for agriculture application, cooling water in industry, process water in industry. And I'll come up with some examples later more. That will give us the manufacturing experiences and gain the first revenues to bridge to the large-scale applications of power plants. That is what we are heading for. Our position in the supply chain will be that we will do process design, benchmark engineering, and supply the key component, the membrane stacks, both for the desalination of brackish water and, of course, the large-scale power generation. This is how it will look. We start in the market with desalination and other ED applications, and heading somewhere in 27, 28 at the ultimate market power generation we will enter. Our team is a bunch of engineers where we started with. We added on some mechanical design engineers. We added on some business development guys, and it's led by Mr. Rick. He's an experienced entrepreneur in water and infrastructural works. And at the right-hand side is Simon. He is one of the first graduates from the Wedges Institute, where the whole technology is backed by. Myself, I think, an experienced entrepreneur in the sustainable and water technology for close to 40 years in the meantime. So, if you're ready to join us in making not only a contribution, but also a business in the energy transition, you know where to find me. Thank you.